I am going to commence this afternoon's meeting officially, and our purpose is to review some of the functions that I referred to 2 weeks ago. We're also going to take a look at Bob Francis's homework solution and his SuperClean function. We also have Rich or Dick Barrett, who took the easy route, but I'm impressed. He took an easy route with ASAP utilities, and he expanded upon it, and he used wildcards with it. So uh, Dick Barrett is going to chime in, so it's a real collaborative thing. Computers 101 is laying the foundation also for when I use the term, and when we used the term last time, ASCII, the American Standard Code for Information Interchange. That's what allows one computer to easily communicate with another computer, whether it be a PC, whether it be a Mac, whether it be Unix or Linux. And the foundation of that is a binary system. The binary system consists of bits, ones or zeros. In the days of punch cards, we either had a hole or we didn't have a hole in a punch card. So it's on or it's off. It's a 1 or it's a 0. 8 bits makes up a byte. And if I have my bytes numbered 0, 1, 2, 3, 4, 5, 6, 7, starting with 0, there are 8 bits here. And if I give them a value, power of 2, because it can be on or off. So if it's on, it's a 1, but the power of 2 to the 0, I'm going to click on that, 2 to that cell, 2 to the 0 power has a value of 1. So if that switch is on, it has a value of 1. Now that switch is off. This is the actual binary sequence I have, 0, 1, 0, 0, 0, 1, 0. So that switch is off, so it has a value of 0. If this switch is on, which it is, a 1 means it's on, it has a value of 2, 2 to the first power. If this switch is on, it has a value of 2 to the second power, which is 4. That switch is not on, so it doesn't have the value of 4. If this switch is on, it has a value of 2 to the third power, 8. This switch would be 2 to the fourth, 2 to the fifth, 2 to the sixth, 2 to the seventh. So these are the values if those particular binary switches are turned on. Well, if I turn on switch number 64, or switch number going from 0 to 6, switch number 6, 2 to the 6th power is 64. So that has a value of 64. And this switch, the value of 2, 66, that value 66 is then interpreted by the system, the operating system, other components of the system, to what we refer to as the letter B. The letter B does not exist on the computer. The computer only has ones and zeros. The number 100 does not exist on a computer because the numbers are binary numbers, and the only numbers that we generate with ASCII are 0, 1 through 9. So the standard that was developed, I don't know exactly when, maybe John knows the history of that.
Yeah, I'm looking at it now. It was developed in, I'm looking for the date, 1963, by the American Standard, United States of America Standards Institute, which became the American National Standards Institute.
Miss.
Now, if I I have a link here. If I go to my ASCII code table here, can you see this screen?
Yes.
Okay.
Mhm.
Um, this screen shows the numbers 0 through 31, and these particular ASCII values, and it shows the binary sequence that generates the equivalent of those decimal numbers. It shows you these are what we call control characters, and some of them we still use today. Carriage returns we use, which is ASCII 13. Line feeds we still use, which is ASCII 10. So from 0 to 31, we have what we call control characters. And then starting with 33, we have symbols. And then the numbers start at 48, 0 through 9. Again, there's no 10, there's no 100. It's the system, it's the whole package that generates our understanding of the words that we deal with in word processing. It's the whole thing, the whole package that deals with generating numbers and doing the multiplication. There is no multiplication or there wasn't any multiplication when I studied computers in Computers 101. It only could add or do the opposite, which would be subtract. Now, starting with ASCII 65, we have the uppercase A, B, C that goes in order. And then we have the lowercase starting at 97. So what we're looking at when we deal with, can you see my original screen now?
Yes.
Okay, what we're dealing with when we deal with the ASCII, when I say ASCII to you, it's a standard code. Just again, if I change this sequence of the binary numbers, and the way I'm going to be doing that, I'm pressing F9, which is to recalculate. I've turned off the calculation from automatic to manual. So if I hit F9, I get a whole new sequence of binary numbers, and the binary numbers converted to decimal is 175, which we won't get into, but um, each time I press the F9 key, I'm getting a different generation of decimal equivalent or the ASCII equivalent. And in this particular case, that's a control characters. It's between the 0 to 31 range. 32, it turns out, is represented as a space. So if I were to have the binary sequence that equaled the decimal 32, that would be represented on the computer as a space. And if I get a different sequence, if I get certain sequence of 32 plus 128, if these two switches are turned on, 28 and 32 is 160. And then if I represented the character that represents the ASCII, you won't see it. It's a space, but it's an invisible space. So what we're going to be doing is we're going to be looking at different ways to find that space using built-in functions in Excel. And there are some other things that these functions do, but I'm going to concentrate mostly on the fact we want to clean up data. So I'm going to start with reviewing some of the functions. For example, if I start with my name is, it looks pretty straightforward. And if I counted the characters, there would be 17 characters. If I do the clean function, the clean function removes a hidden character there. So what's going on here? If I take a look at this just as my name is, what I did and what we often do in Excel is we put things on two different lines. How did I do that? Well, if I do Alt and the Enter key, it does a text wrap and drops it down to the next line. Well, that Alt and the Enter happens to be a control character. It's one of the numbers from 0 to 31. It's, I believe, character 10. It's doing a line feed. So you don't see that initially.
Okay.
The character here with clean is stripped. And so it just truncated whatever character that was. And as a result, the len of the clean function now is 16 characters because it no longer has that hidden character. The trim function also is taking off a space that might be at the beginning or it might be at the end if we have text. And the character length now is 15. So let's take a look at these two functions. The clean function simply is equals clean, and it refers to the original cell, which I had, again, I had a text wrap. So that character, you can't see it, but it's there. And you don't even have to, when we do this cleaning, we don't have to know if it has a hidden character or not, because what we're going to be doing is we're going to use all of these tools. We're going to use the clean function, we're going to use the trim function, we're also going to use the substitute function. But the clean function is straightforward in terms of clean, and it refers to a cell. That's all you have to do to clean any hidden characters. Okay, any question on that? Okay, the trim function will take characters away from the beginning or the end if there are any extraneous characters. And I think when I did this, I probably put in, yeah, I put in an extra character at the end on purpose. So the trim function is taking away the character at the end, not that hidden character, that ASCII 160, but it's taking away the character at the end. So the trim function is, it looks like the same text as the clean function, but it's stripping off the character at the end. Therefore, the len is only 15. And the len function is straightforward. Len and the cell reference. Len, cell reference. So clean, trim, and len all refer to a single cell. Clean, the cell, the original cell. Trim, the original cell. And now substitute. Substitute is quite interesting because substitute, oh, by the way, clean goes through each character in the string. It's as if you were doing a mid string and going character by character. So but you don't have to do a mid string and find the hidden character. Clean automatically goes character by character. Substitute likewise goes character by character. And what it does, it can look for certain values and replace them with other values. So substitute is looking at cell E2, looking for my name, Fred, and replacing it with Judy. And the result is my name is Judy. Now keep in mind, if you do stuff like this, that substitute is case sensitive. So if I typed in, see, lowercase f, it does not find it. Substitute is case sensitive. It has to be a match. Now to get around that, since you don't know if you ever need to use this function, you don't know if the cell is uppercase or lowercase, you can stick in an upper. Upper will convert text to uppercase. So if it starts out as lowercase, and you convert it to uppercase, let's see what happens. Oops, sorry, my logic is not right here. My logic. It's just the letter F. Let's see. I'm going to cheat. I'm going to make my name over here. I'm going to make my name over here, all caps. Okay, so my name is in caps. Oh, I know what I'm not doing the F9. I'm sorry, I forgot. I turned off the calculation, so things may not happen in real time. I'm going to probably have to turn that back on when I move on to another sheet. So by hitting F9, it recalculated and looked at the fact that this is lowercase typed in. I don't know if it's lowercase or uppercase, so the upper function converts everything to upper, and it then is a true statement, and that it does the replacement. Let me give another variation of that and see if that works. If I go back here and change my name to all lowercase, okay, my name is lowercase, whoops. Okay, if I hit the F9, it's going to work or not going to work? Okay, it's not going to work because Fred is all lowercase. Can be confusing. The point is, substitute is case sensitive. Questions or comments? The way we're going to use substitute is going to be used to replace spaces. In trying to eliminate spaces, I can use let me move the screen over a little bit. Okay, I can look for a space. Here is literally a space, and I can replace it with a null. A null is double quote, double quote. So the reason for that now is I may not know where the spaces are, and by doing the substitute, looking for a space, it may be in the middle, it may be at the end, I can just strip out all the spaces and get rid of them by using this format. Substitute, looking in the cell, looking for a space, and replacing it with double quote, or a null. Okay, we're going to be using that because that's part of the solution in cleaning up data on the internet. When you get data from the internet, it has that 160. And what we'll probably be doing is we'll not just be looking for a space, but we'll be looking for character 160. Instead of a space, we'll look for character 160 and replace it with double quote, or a null. You can also do multiple substitutes, substitutes within substitutes within substitutes, looking for, with a phone number, looking for a hyphen, looking for a comma, looking for the parentheses. I'm not going to go through the analysis of that, but this is a way in which you can look for multiple situations. You look for character 160, you can look for a space, and you can kind of put them inside each other in order to get your result of getting a null. A null would be a blank. Okay, the other thing I'm going to review then is match and index. Okay, match has is a function, and it looks into a cell, in this case looking into cell C2, as the lookup value. I want to see if apples is a part of this list here of fruits. Fruits is a named range. If I go to my name box, I see that fruits are the cells A2 through A5. If I do it this way, B, C, U, G, and I have John, Rich, and Fred. Okay, if I have these cells and I highlight all of them, and I want to define that the name of that range is BCUG, if I go into um, formulas, create from selection, that's what the one I want, create from selection. What it does, it takes the selection that I have, and it takes the top row, which is BCUG, and that's going to be the name of John, Rich, and Fred. So if I say OK, and now if I go and look up here, I have BCUG as my range, and so A9 through A12 is my named range BCUG. What I did was I named the range A2 through A5 as fruits. So you see these are highlighted because I did it the same way. I selected the all the cells in the range, and then
I have a question.
Sure.
I want you to go into cell B2 and put a 1 there, and in pardon me, B8, but it doesn't matter. B8 is 1, B9 is 2, B10 is 3, and B11 is 4. Now, these are my constants, my absolute values. I'm going to use them in other places in my worksheet. And 1, the name of 1 is BCUG. The name of 2 is John. And so wherever I go in the worksheet, if I type in equals John, I'm going to get a 2. Now, how do I go to cells B8 through B11 and name the cells in the column to the right?
Okay, good question. Okay, it's along the lines of what I just did. If I highlight those cells and go to formulas and use create from selection, that's what I was missing last time. It prompts me. It says create the names from the values in the left column.
Okay.
And if I say OK, I'm replacing BCUG with this cell. So if I go to BCUG now, that's that cell, that constant. If I go to Fred, that's that constant. Does that answer your question?
Yes, let me just get the sequence of, so I go to data.
You highlight the cells.
Highlight.
Go to formulas. Create from selection.
Okay.
And it prompts you. Now you don't have to do it that way.
Mm-hmm.
You can just stay in that cell, go to the name list, and type in whatever name you want. You can do it. You can do it this way too. Okay, so I can name that constant by just being in the cell and going to the name box.
Mm-hmm.
Okay, back to match. Match is looking in cell C2 as my lookup value and then comparing it with fruits, these 4 cells. The 0 represents the fact that I want to have an exact match. What match returns is the position in the list, position in the array or in the list. So if I'm looking up peaches, and I have to hit F9, sorry about that, it finds it as position number 2. If I type in plums and hit F9 to recalculate, it finds it in position 4. If I type in something that's not in the list, and hit F9, I get an error, a not available error. So match returns the position only. It does not give you the value. Index is what we need for the value, the index function. The index function is looking at the array fruits and pulling the position from whatever the match function found. They're going to work in conjunction. Index works with match. So if match finds position number 3, 1, 2, 1, 2, 3, index will then return the actual word pairs. So if I put in pairs, oops, wrong spot. If I put in pairs here, hit F9, hit F9, it finds position number 3 in the array. What is the value? Index finds from that array position number 3 and therefore returns the word pairs. And we can do it as an all-in-one. We wrap the match function, we wrap the index function around the match function. So this is just a fancy way of doing it stepwise. These are the steps that are necessary. First you use match, then you use index. So match goes on the inside, and then index wraps around that to give you the result. Question, comment? The words pairs lights up in red.
The cell,
Say again?
the cell unit, or the, not the word.
The cell, yeah, the cell, yeah. The cell lights up. If I hit F9 now, okay, all my apples light up. Okay, how did I do that? John Stampfel mentioned earlier conditional formatting. Conditional formatting can change the format of cells based upon certain criteria. And the way we do that in the Home tab, conditional formatting, we have all these choices. The most common one is to highlight the cells if it's equal to a certain value. In this particular instance, I am using duplicate values. If it's a duplicate value, it's going to light up in that color. And I already did it, so what I'm going to do is go to my rules, manage rules to show you what the rules are. So looks like I've done it. Yeah, I've done it several times. It's showing you that if there's a duplicate value, first I highlight all the cells. I highlighted from A1 to D7, A1 through D7. So I get all my cells highlighted. That's my range I'm applying it to. And if there's a duplicate in that range, format it this color. I can also make it, if a value, back on the other one where I did the binaries, if the number is a 1, I'll demonstrate that because I don't have that one. If I go to my Home tab and I do conditional formatting and I say highlight the cells if it's equal to, and if I say it's equal to 1, okay, it does say 1, and I'm going to make it green. Okay, and it is now green. So if I change this to peaches and hit my F9 key, it's no longer 1, it's false. So therefore it is not going to light up as green. That's what conditional formatting means. Questions, comments? Okay, now putting this all together, the homework last time was to compare two lists of email addresses, column A and column B. And
Fred, that may be a little small for us See,
Oh, yeah, I just took it as is, right, there we go. Now we're not gonna see the whole picture here, but better?
that's good for me. Anybody all right?
Better?
Good for me.
Yeah,
And
I'm gonna have to maybe
Yes.
I'll slide the screen along, but okay. We have two columns of emails, and the question is, um, are they the same? The general idea is to compare two email lists to determine if A is contained in B, even if they look the same. And we have a bunch of these functions: trim, match, VLOOKUP if you wanted to, substitute. Okay, so Bob, you want to take over? What did you do, Bob? Turn your mic on. Unmute Bob.
no, you can do that.
Yeah, I first just used match from A to B, and I got all, no, there's no match because the extra characters or whatever was in there. Then I did the length to find out that there was different numbers of characters in each one of them. We're in B actually. I think only B had the extra characters. I don't think A had the extra characters.
Here's what he's saying. He's talking about he did some analysis here. Yeah, he did some analysis and he did a trim.
Right.
He's seeing different lens. Yeah, go ahead.
So after I did that, then I said, well, since I know there's extra characters in here and it's not going to match, so I need to get rid of those first, which is what I did. I did the trim and cleaned off any extra characters with the trim statement or trim function. And then I went in and did the match. I just used match first to see if it was going to match, which it did.
Let me back you up for a minute. You did you did a clean and you wrapped it around a trim. So first he did a clean just in case there was a control character, and then he
Right.
did a trim. He did a super duper clean here. He even did another super duper clean, but he put the trim around the clean.
Right.
Okay, so that's C fixed column A, and he did the same thing in column B.
Right.
Okay, now continue.
Yeah. Since I wanted to put them into a different column instead of messing with the original, because I just cut and pasted this from your email, the
Right.
A and B. I just cut from the email and I put it in. So I want to keep that the way it was. That's why I created C and D, and then I used the C and D to do the matching, where I'd use the index function
Okay, so he did the match where he took the lookup value in D4.
in D. I was looking. It doesn't matter whether you do it from A and B. Well, C and D, since we're all talking C and D, because A and B are the original with
Correct.
the extra characters. C and D, I've already stripped any extra characters and everything, and they do match. If it
Right.
finds a match, it matches.
Right.
So what I did, it didn't matter. It doesn't matter whether I use in the match in this function right here, which is index, and then it's got the absolute values, and then match. In my match, in parentheses, I have D4 instead of C. So it
Right.
doesn't matter whether I made that D4 or C. If I made it C, then the part of the match, the C, I would have to match the D. Mine is doing a match of D to C. When you sent me your function, you were doing C4.
Yeah, here's mine. Here's mine.
And
Yeah.
right, yours is doing C4, mine's doing D4. So I'm looking at the, what was it, 9 values, whatever it was in D, the 9 to 4. You're doing 4 to 12. That's what it is. 12 is 12 lines. So you're doing C and you're looking at the 12. I did it in reverse where I'm doing the 12 looking at the 4.
Right.
It's not really reverse, but they both do the same thing.
Right. Right. At first
The
I didn't.
logic is a little bit different, but the logic is the same. It's just it looks different.
Yeah, I was thrown off by your logic, but it made sense to do it either way. But you do take a different range of cells. You'll see if you're taking Bob's approach, matches found in D that match C. The range threw me off because I had more cells here, but he went from C4 to C8, which is the original list. The original list
In A.
only had from A had these 5 cells. I was thrown off by that, but it worked in his logic by going and looking at the match from D and seeing whether it was in the C. I just did it the other way, where it took the C and looked into the D. The C is contained in D. So either way will work, but the range may have to be adjusted. Any comment or any addition to that, Bob?
Well, if you look at the original question, you got to understand the question. The question was, you want to find A, well, in this case, you want to find what, if A is in D.
Correct.
So my logic to that, I want to look at D and look at A, because I want to know if A is in B. Well, I keep getting A and B, but let me say with C and D, because that's where I've worked on.
Yeah, yeah.
I want to take and see if C is in D. And your logic is you want to see if, let's see, C, I'm getting confused myself.
Yeah,
I'm thinking about it because of the works around.
Yeah.
But it's the way the question is worded. You want to know if C is in D, or if you want to know if D is in C. That's
Right.
the thing, and it comes out the same either way you look at it.
Right. Go ahead, Mike.
The Bob's version of this puts the answers on the lines that they're in, whereas yours seemed not to. But you're past your, you got to scroll over so I can see that part.
Yeah, right. Yes.
Okay, so then you see the lines that don't match, and if you wanted to delete them or move them separately, it might be simpler that way.
Okay. Good point. Good point. I just want to call your attention to a super duper function. When you start to clean data, rather than you don't really know what the problem is until you have a problem. So if you want to clean your data, you can wrap the clean around the substitute, looking for character 160, and then you can trim the whole damn thing in all one master super duper function of Bob's. So this is what Bob, I believe you wrote this, right, Bob? You wrote this.
Yes.
Okay. Now, one thing that I learned is that you really don't have to change the character 160 to a normal space. What you can do, and I illustrated it earlier, is you can take out that space altogether and make it look like that. There's no need to replace the character 160 as a real space when what you want to do is you want to clean it up. So that's just a small addition to what Bob sent me. But the idea is you wrap one function around another function, or you can do it step by step, as most of us would like to see it work step by step. Those step by step columns are what we call helper columns. Okay, let's give Bob Francis a round of applause. He's the Excel participant of the month. He gets to park in the first virtual parking space. It's in recognition for his dedication, passion, and hard work in completing the homework challenge.
Thank you.
Well done, Bob. I appreciate, like I say, Excel workshops, for those of you who are joining us for the second or third time, are much more lively, but in general, our workshops are very much a participatory kind of thing. And I welcome that because it makes it rewarding. I mean, it's a two-way street when we work in Excel. It's not a one-way street at all.
I just wanted to make a comment while
Sure.
we're still looking at stuff that has match in it.
Yes.
If you have Office 365,
Yes.
Microsoft has added to the VLOOKUP, the lookup functions, and the match function
Right.
that they automatically cache the whole thing. They made them much faster. If you have anything other than Office 365, you do not yet have those speed ups.
Okay.
But if you're going through, a million line table and looking for something, or even thousands, and you notice that it's affecting the speed of the lookup, and you have Office 365, you shouldn't notice. It'll be faster. You won't notice because either it's slow because you don't have Office 365, or it's now real fast that that they create a hash of whatever you're going to use in the function. That's what they do. They create a hash so they can do a very rapid lookup.
Okay.
But that's an Office 365
Yeah,
feature.
the data most of us have is not going to be affected by that. Our data is, just hundreds, maybe at the most. I have mailing lists that are between 100 and 200. I'm not concerned about speed.